Hello everyone, welcome back to my channel again. So in this video, let's solve one more model question paper question that is from model F4 or else unit 4. Okay, I'll solve two questions. One more question we'll solve in next video again due to shortage of time. So let's go for 8B. It is very important, the waveform synthesis. So I draw the waveform, sawtooth waveform, and it is a periodic signal or else periodic function, periodic waveform. The formula for periodic waveform is this. That is f of s equals 1 divided by e to the power minus ts. T is difference between the cycles. Okay, so periodic signals into f1 of s. F1 of s means you have to consider one waveform for this. So now it is a continuous waveform from 0 to a to 2a, 2a to 3a. Okay, sawtooth. So let us consider one cycle. Consider one cycle. So now, by considering one cycle, let's draw the cycle. Cycle. It is f1 of t. So one cycle 0 to a. Okay. So I have to find Laplace transform from one cycle, then you have to substitute here. You'll get Laplace transformation for periodic signal or this periodic waveform. So now let us know how we can generate this waveform. So from 0 to a, it is having a slope of or else a magnitude of 1. So ramp signal is generating, so that the first step you need to generate ramp signal. So I'm generating ramp signal with respect to t. This is fa of t. From 0 to a, ramp signal is generating with a slope. So now we calculate slope is nothing but y by x. That is nothing but 1 divided by a is a slope. So that you can write 1 by a into t into u of t. You need to add this with, so this is going on till infinite, so you need to break this at a, so that for the second condition you need to break this, or else you need to break the ramp waveform at a, that is fb of t. So I have to generate one more ramp waveform in a opposite direction, or else negative ramp signal you need to generate. So here the slope is negative, so that minus 1 by a is a slope, minus 1 by a is a slope into, and there is a shifting of waveform from 0 to a, so that t minus a into u of t minus a. So if you add these two, you'll get waveform like this. You can get waveform like this. This is 0, 1, it is a. And again, you need to break this with a step function in negative half cycle, so that you have to add this waveform along with the negative step function, so that plus negative step function from a with a magnitude of minus 1. So this is minus 1, so that minus 1 into, here it is a, so shifting of waveform, so that minus 1 into u of t minus a. If you add these three, you'll get first waveform, that is a sawtooth waveform will get. So that, so now let's add f1 of t is nothing but 1 by a into t into u of t minus 1 by a into t minus a into u of t minus a minus 1 into u of t minus a. So you can get this. So now you need to find Laplace transformation from, for this you need to find. So that you can get Laplace transformation of t with respect to u of t, that is 1 by a into slope into 1 by s square, that is Laplace transformation of f1 of t. It is nothing but f1 of s minus 1 by a, as it is Laplace transformation of ramp function, so that 1 by s square into e to the power minus sa minus unit function 1 by s into e to the power minus sa. You need to substitute here for the periodic function. So what periodic function says, f of s equals 1 divided by 1 minus e to the power minus ts into f1 of s. So here t is nothing but time period. You just see here for t, a to 2a, 2a to 3a, that is 2a minus a, t equals a. Therefore, f of s equal 1 divided by 1 minus e to the power minus as into f1 of s is nothing but 1 by a square minus 1 by a s square into e to the power minus sa minus 1 by s into e to the power minus sa. This is a function. If you want, you can simplify. You take 1 by s as a common, or else you can take whatever, or else you just have to keep as it is. Okay. And now, if you want, you can take screenshot also for this. It is very easy. If you want, you can take screenshots of solution. This is more than sufficient for 6 marks. Okay. And the first question what they ask, that is a definite question. Definite question I am mentioning means that you can definitely get that in examination. That is initial value theorem and final value theorem. So you should know about this initial value theorem and final value theorem. Question number 80. State and prove initial and final value theorem. So now initial value theorem, the Laplace transform is very useful to find initial value of time function f of t. Thus, if f of s is the Laplace transformation of f of t, then you need to prove this. That is f of 0 plus is nothing but limit t tends to 0 plus f of t equals to limit s tends to 0 s into f of s. This proof you have to do. Okay. Note f of t must be continuous. So proof you have to do. For that you have to consider property of linear transfer theorem. That is nothing but real differentiation property. L Laplace transformation of df of t by dt is nothing but s into f of s minus f of 0 minus. So for this equation, apply limit on both sides, which tends to infinite. So that limit s tends to infinite, you are applying on both sides. Limit s tends to infinite, Laplace transformation of df of t by dt equals limit s tends to infinite s into f of s minus f of 0 minus. You are giving this as equation number A. Next, consider only LHS, this one. Limit s tends to infinite into Laplace transformation of df of t by dt is nothing but Laplace transformation of this is nothing but this is f of t. So that limit s tends to infinite, integration from 0 to infinite e to the power minus st into f of t. F of t is nothing but df of t by dt. Differentiation and integration will get cancelled. We'll get only e to the power minus st. So here you just apply limits. So by applying limits, e to the power minus infinite is nothing but 0, e to the power 0 is nothing but 1. By applying limits, you'll get 0 on left hand side. So now we substitute this value to the equation A. LHS ಅಲ್ಲಿ 0 substitute ಮಾಡಿ 0 equals limit s tends to infinite s into f of s minus f of 0 minus. Now we send this to right side. We'll get f of 0 minus equals to limit s tends to infinite s into f of s, where f of 0 minus is continuous. F of t is continuous, so that f of 0 minus is same as f of 0 plus. You can write it as f of 0 plus equals limit s tends to infinite s into f of s. This is the proof. Only this much you have to. It is very easy and you can easily write an examination, so that if you want you can take a screenshot also. Similarly, next we need to write it for final value theorem. So final value theorem, what it says, f of infinite. 0 is initial, infinite is final. So that f of infinite is nothing but limit t tends to infinite, f of t, that you have to prove limit s tends to 0, s into f of 0. So again, you are using real differentiation, Laplace transformation of df of t by dt. This is a from property of real differentiation. After that, you are applying limit on both sides. For initial value theorem, you are applying limit s tends to infinite. For here, you are applying limit s tends to 0 on both sides. Now we are consider LHS, limit s tends to 0, limit s tends to 0 into Laplace transformation of df of t by dt is nothing but e to the power minus st. Again, differentiation and integration will get cancelled. What will get, you're applying s tends to infinite, s tends to 0, wherever s there, you will be substituting it as a 0. It is nothing but 1, and this is nothing but f of t. So e to the power 0 andre 1 agutte, ಉಳಿದಿರೋದೇನು, so you'll get integration from 0 to infinite d f of t by dt. It is nothing but f of t. So that you're writing f of t with the limits infinite to 0, f of infinite minus f of 0 minus. So you're substituting into the equation A again, left hand side ಏನದಲ್ಲಿ you're substituting f of infinite minus f of 0. Therefore, you'll get, after substituting, you'll get the final answer. Okay, just take a screenshot. It is very important. Definitely they will ask in examination. Okay. So if you're having any doubts regarding this, feel free to write in a comment box. If you really like this video, do subscribe and share maximum. Have a nice day, and once again, all the very best for your examination. Thank you.